Hi, my name is Keith Littleton. I'm the Automotive Program Manager here at Jones Technical Institute in Jacksonville, Florida. We made a series of videos about the fault box. Fault box is a trainer that you install on a vehicle that allows you to put faults in the vehicle, and your students would be able to diagnose those and learn process and these types of things. So this particular video, we're going to be talking about the fault box installation considerations, kind of the preparation before you actually stick the fault box on your vehicle. Okay, fault box installation considerations. The first one is choosing your subsystems. Okay, we're going to go over each one of these in detail in just a minute. Second one is, do you want the fault to provide you a code or no code? Just a symptom with no codes. Third thing is, where are you going to put the fault box? You're going to put the fault box in the trunk of the car, you're going to put it in the floorboard, you're going to wrap the harness up in the kick panel. You know, you got to think about those things before you go on. A lot of guys like to put it in the trunk, so you have to run the harness you know, through the body of the vehicle, under the carpet and these types of things. So that's another thing that you want to think about. Fourth thing, circuit specifications must be assessed. What's the amperage draw? Are we going to damage the fault box? All these things are in your installation manual to be aware of. So these four items we're going to go over in detail. Okay, the first one, choosing your subsystems. Okay, subsystems, I just threw some examples up there: engine controls, fuel supply systems, powertrain control, lighting systems, brake systems, ride control, body electric, chassis electrical. These are just examples. So the idea behind that is you could actually have a harness for each one of those subsystems on. You could do it on one vehicle if you want. There'd be a lot of harnesses on one vehicle, but my suggestion is not to use more than 3 harnesses per vehicle. I have a few vehicles out in the lab right now that has engine controls, powertrain control, and lighting systems, and other various configurations of that. But just make sure you pick the subsystems. And I normally stick the harness with a particular subsystem. That's just how I do it. So, okay, code or no code? Second thing to consider. Okay, is it a single or 2-trip code? Or are you going to be able to accomplish that inside the lab? Just think about that. So if you're wanting a particular code for the students to diagnose, you just have to make sure that the fault box will give you what you want. The criteria to set it. Okay, is an open circuit going to set it? Is high resistance going to set it? These types of things. Is it intermittent fault? If you get the intermittent box, is that going to cause it? So just make sure to look at the criteria. Is it single trip, 2-trip? Does it require a test drive? Most training centers, you know, if you don't have a test track or something, normally you can't drive your training vehicles. There is some schools that can, but just be aware of that you know, the vehicle, if it has to take a test drive, maybe you got a dyno or something, but just be aware of that when you're putting the faults in. And what is the goal behind it? Do you want the students to learn how to do a voltage drop test? Do you want them to learn how to check for open circuits? You know, whatever your goal is, just make sure to have a plan on that second system, whether you're going to put a code or no code in it. Those are things that I feel that you should consider. Okay, best place for the fault box. Where to gain access to the chosen circuits. One thing you've got to be aware of is if you're going to do, for example, engine control circuits, you're probably going to tap into the harness right as it goes into the PCN or just back from it. It's one access point and you can get to a lot of circuits at the same time. So you don't have the harness running all over the vehicle and having to cut it and modify it. So just make sure to really think about that where you're going to gain access. Routing of the original harness. You kind of want to hug your harness or make it look like it's a part of the harness. You don't want the students to be aware of the harness. So just make sure wherever you're running the harness, you know, you can peel it out and put it right in with the other harness. Just make sure to be aware of how they're running the harness. You don't want to run it by certain things, which we'll go over here in just a minute. Best routing for the new harness. If you put it up underneath the engine compartment, and as you leave the engine compartment, make it look natural as it comes through the firewall. I've even taken it through the fender, inner fender, and then came through certain areas in the body panels and up in the passenger compartment. So just whatever the best routing is, just have a plan for that before you just start, knocking out rubber plugs and just pushing the harness through there. Avoid anywhere where it's going to be near the exhaust, the engine block, things that's going to damage the wiring. The EMI, you don't want to sit it next to something that a magnetic induction is going to change the sensor readings or even affect the way the car runs normally. And then pinch points, just make sure you're not putting it where something's going to get taken off and put back on and get pinched. So those are definitely things to be considered about where the fault box is going to go. Last, the fourth area is the circuit specifications. Now these are critical. These are things that you got to plan for. Whatever you're going to put the fault in, is it power control, controlled or ground controlled? Does the current exceed what the fault box is set up for? Okay, and all these things are in your instruction manual. I don't want to give you a number, but because some of the fault boxes are a little bit bigger, smaller. We got heavy-duty truck boxes that handle a little bit more amperage. So just make sure to look at your installation manual to make sure that the faults that you're putting in there is not going to damage the box. Faulted circuits affect unwanted circuits. Yeah, you got to be careful wherever you're tapping in. Have a plan. We're going to go over that here in detail in just a minute. Actuator faults in series, faulted control line towards the controlling device. What that basically means is, let's say for example, the negative control for the injector is coming out of the PCM. If you're faulting the actual injector, use the one that's coming out of the PCM and follow the instruction manual. So when you're looking at your breakout panel at the bottom of the fault box, right here, you're actually picking up the particular circuit at that breakout panel that you're wanting to fault. Another example of that is if you're using, let's say, a throttle position sensor and you're using the signal circuit, make sure that you're faulting the signal following the installation instructions, and I believe it is the wires with a tracer, I believe. But just make sure to look at that in your installation manual. All the ones with a tracer, I believe, are the ones that are the signal going back to the PCM. Okay. The last item here, incorrect installation can damage the fault box or the vehicle, which I know that seems like a no-brainer, but just be careful. Be careful when you're putting particular faults in and be aware of what you're doing and kind of have a plan before you go there. So that's basically the considerations before you get going. Now, what I've done here is the suggested faults, and I just picked engine performance area. Because again, like I said, I use the harness per subject area or per subsystem. So here, these particular three switches on the fault box are, they're just named communication faults because the fault box was designed to give a variety of certain faults. So the suggested faults that I'm using, and this is on a 2008 Camry, is C1. This particular switch here, I'm going to fault the communication that you would have coming down to the DLC connector, the diagnostic connector. And what that's going to do, that's going to allow the students to put the scan tool on it. Maybe they have a check engine light that you've set on their form, a mill that's on, and you want them to check codes. You want to teach them that when you stick it up there, if you have no communication, how to diagnose that. So with a flick of a switch, car is fine, but the communication is not getting from the PCM actually to the scan tool. And that's what one of my suggestions are. It's a really good fault. Fault number 2, on this particular vehicle, the 2008 Camry, I picked CAN high circuit going to the instrument cluster. Toyota calls it the combination meter. It's a pretty neat fault. There's some details in there that are pretty neat. It does some pretty neat things, and I don't have time in this video to go over that. But in future videos, we're going to have, when I put a fault in a particular vehicle, I'll show you all the different things that happen to the vehicle, which you'll find out as soon as you do it. Fault number 3, C3, certification ECU on the Smart Key system. Basically, the open circuit in the certification ECU for the communication, it can't verify that the particular key that you have is the correct one, so the vehicle will start install. So really good fault there. The students make sure that they follow a procedure on this one, because they could spend a lot of time trying to figure out what this one is. So, but those are the 3 communication faults that just a recommended fault on, you know, they may be called something different on a particular vehicle that you have. But on the 08 Camry, that's what these are. And of course, a parasitic drain. This one here is pretty much the same on every installation. You provide 12 volts battery voltage to that particular switch, and it has fixed resistors in it, and allows a 40 milliamp and a 80 milliamp draw up and above what's already in the vehicle. So the next 4 faults here, A1 through A4, we call those A because those are a higher amperage fault. Okay? And again, look in your installation manual, it'll give you the specs on what's the highest amperage there. On this 08 Camry, the next video, by the way, is going to show you the actual installation of all these particular faults on a vehicle, step by step. A1 through A4. So A1, injector control. A2, O2 sensor heater. Then A3, the PCM relay circuit. And A4 is the EVAP vent valve. Pretty neat things happen when you mess around with that EVAP vent valve. And I'll tell you some little tricks that I've done in the past with that one too. So. But those are the suggested faults for those particular faults in the fault box. Now the last 4 here, the sensors, I did pedal position, if you have that, or if you want to use throttle position out under the hood, you could do that too. You know, either one of those. I'm probably going to do pedal position on this particular vehicle. The fuel level sensor, pretty neat one, and we'll go into detail on that one in future videos and how I use it in training. Crankshaft position sensor and engine coolant temp sensor. Now, one of the reasons why I suggest on every single harness that you're going to use for engine controls to put the coolant temp sense in there, because we put a potentiometer right here on the fault box. Well, you can actually control temperature of the vehicle, what it thinks, what the ECM thinks the temperature of the vehicle is. So you can do cold soaks, you can fool the computers and still letting the vehicle sit overnight if you have to run a monitor or these types of things. So you can show the students fan control, bring it up to a certain temperature, the fan should kick on, and these types of things. So really nice fault there. You can make hard starting conditions, you know, rattle it up to 215 degrees when the engine's still cold and try to start it. So anyway, so those are my suggested faults for those. Now, this other little switch here is the intermittent. I'm going to have a whole video about that intermittent switch. So a lot of detail there, a lot of things you can use that for. So in this particular video, I'm just going to skip over that one. Okay, so let's move on. Examples and why. Okay, C1, what we just talked about, circuit 1, for communication. This is the one where the scan tool doesn't communicate with the vehicle. So basically you have no communication scan tool. Students must decide whether the vehicle, is it a vehicle problem or is it a tool problem? If the middle light's on, you know, the student's got to decide, how do I check codes on this vehicle? What am I going to do? So it's a diagnosis thing with them if the scan tool won't communicate. Demonstration of communication with an O-scope. Now, on the breakout panel on here, you flick the switch to a normal position, and then you can demonstrate right from this panel what normal communication looks like on an oscilloscope. So, anyway, but C1, just wanted to give you kind of my thought process on why I picked that particular fault. And these are just examples of those other ones. I don't want to make this video too long. I want you to watch it. So, I'm just picking examples of each one of those areas. Okay, so the next one, well no, I'm sorry. What we're going to do now is I'm going to show you actually where I faulted that C1 actually on the vehicle. Okay, now this up here is the diagnostic connector on the wiring harness. Hopefully you can see this. And where that little arrow came up, let me push it back down. Little arrow comes up, that's the communication wire that goes back to the actual PCM. So all I did on this one was I just cut the wire, just like you see there. Whoops, sorry. I cut the wire so you can see DLC connector, that's the fault location where the arrow is where I've cut it. So the fault box would be tapped into that particular circuit. So you can complete the circuit or open the circuit or put a fixed resistance in that particular circuit. Okay? Next example, A1. This is the higher amperage faults. What I did on this one is I dropped battery voltage to the ECM through the EFI relay. Okay, so let's take a look at that. It provides a no start condition with no codes. Students are going to, if they bring in a crank but no start, they're going to have to diagnose ignition system, fuel delivery, etc. They have to go through that, what I call a 10-step process. I've developed a 10-step process to kind of determine where that problem lies when you have a crank but no start. So there's a lot of training involved when you drop the PCM, because you lose injector pulse, and sometimes you lose a spark on certain vehicles and these types of things. Third thing here, diagnosing the circuit, the relay, the voltage drop, and using a wiring diagram, EWD. So, and I'm going to go over that here in a minute, but there's a lot of great stuff when you drop the power to the PCM. Okay, now here, this is the particular circuit that I faulted, the actual one on the 08 Camry. You can see the EFI relay here, okay? And, whoops. So, there's the EFI relay. Now the EFI relay, whoops, if I can get going here. If you notice there where that arrow is, the main fuse comes over and provides battery voltage to the relay. Then the relay will take that battery voltage and bring it up to that particular circuit. And then if you follow the arrow again, it takes it over right to the PCM. Okay? So in this particular fault, what I did is I snipped this particular wire at that location. So now the relay actually does not get battery voltage. Now, if you look at that particular fuse, if the students checked it at the EFI main fuse, it would show battery voltage. So a lot of times the students are going to jump to, okay, let me replace the relay. Maybe not, but there's just a lot of quality training, and I'm sure you guys are going to see this as, okay, if I drop it there, then the student's got to check the operation. He's going to have to check battery voltage here. If he misses that step, then he comes over to the control side. How's the student going to determine that? So a lot of good training there. You could always drop it here. You could drop it, at the control side on the coil. You could take the ground away from it if you wanted to. So many different options. I just chose to do it right there. Okay, last section, the engine coolant temp, as I mentioned before. You can open the circuit, you can do a fixed resistance, or you can do a variable. As you remember, I told you here, we put a potentiometer in the fault box so you can change the resistance so it's not the same thing every time. Okay? So you can diagnose hard start problems, turn the mill light on, fuel trim situations, cold soak, as I mentioned before. Let's say if you have an evap system that has to sit through a cold soak before it sets a particular code. And then the fourth thing here, demonstration of normal temperature rise. You can actually tap into that circuit with a digital multimeter, or however you want to do it with an oscilloscope, and you can watch it rise. Have the students time how long it takes a vehicle from ambient temperature to rise to running temperature at what RPM, these types of things. So it's nice to have that sitting there. Now, could you do it with a scan tool? Of course you could. But you could do it right from here using a digital multimeter too. And if you guys are like me, I like them to be able to fix some things with a digital multimeter as well as a scan tool. So, okay, let's move on. Okay, and this is where, there's the piece of the ECM, PCM, and I just put the little arrow up there so you can see where the circuit actually comes in to the actual PCM, and then I faulted it right there. So there's the engine coolant temp, so your fault box comes in, fault box will come in right here with its wiring and then leave and come back to the fault box, so when you have it in a normal position it just completes the circuit, or you can control it with the potentiometer and put a fixed resistance or just an open like it shows there. Okay? So those three, I just gave you an example of each one of those and what you have to consider and decide before you put the fault box in. Okay? And of course, you can save this video if you want to steal my suggestions. That's fine. You can do it that way too. Okay, now I put the fault box here just so you can see. When I call this a breakout panel, I'm just calling this little row down here of access points. That's what I'm calling the breakout panel, because that's basically what it is. So I gave you examples of communication faults, amperage faults, and sensor faults, and of course, the engine coolant temp sensors are a real nice one to use with that potentiometer. Now, of course, you can use it for the other ones too. Just the engine coolant temp is the example that I chose. So that's it for that. So thanks for watching the video. Hopefully you picked up something from it. What's nice about the video, if I talk too fast or something, or we made it go too quickly, you could always run it back. But so this video was designed just so you could see the considerations and things that you need to prep for before you install the fault box, with the wiring diagrams and kind of the thought process of what subsystem you're going to use. Make sure the fault box is put in a location in the vehicle that's convenient for you and what you want to get out of the training, and these types of things. So the next video we're going to do is going to be on the physical installation of the fault box. And I'm actually going to use those same faults that I just showed you there. So thanks for watching our second video, and we'll have more to come here in just a little bit about an actual installation for the fault box. Thanks.